Are you prepared for what's coming up? The red supergiant star Betelgeuse, which is closest to Earth, began to dim significantly in recent years, which sparked both excitement and anxiety throughout the entire planet. Because of the random dimming that frequently precedes a supernova outburst, several people believed the main event was about to occur. Betelgeuse has recovered brightness since then, but it has not yet erupted. It is a conspicuous star in the constellation of Orion the Hunter. Dimmed, brightened, and now seems to be returning to a less active state. Betelgeuse is undoubtedly getting close to the end of its life, and scientists are concerned about the size of the explosion it will unleash when it decides to end everything. How soon will Betelgeuse have a supernova, and will Earth be destroyed in its explosion? You will get to know this and many more as we dive into detail. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcome. The location. Along with the Great Bear and the Southern Cross, Orion is one of the night sky's most recognizable constellations. Rigel and Betelgeuse, which are technically designated as Beta and Alpha Orionis, and are both brighter and larger than the Bear and the Cross, are two first-magnitude stars in this constellation. Astronomers have discovered that the brilliant red supergiant star Betelgeuse literally blew its top in 2019 after analysing data from NASA's Hubble Space Telescope and a number of other observatories. Betelgeuse experienced a major loss of its visible surface and produced a large surface mass ejection, SME. This has never before been seen in a star's behaviour. Such a coronal mass ejection, a CME, which regularly affects our solar system, is a process wherein a piece of the corona, the sun's fragile outer atmosphere, gets swept away. However, compared to a typical CME, the Betelgeuse SME discharged 400 billion times more mass. Therefore, it seems that the hot gas cloud that the star ejected, which momentarily obscured some of the star's light, was what caused Betelgeuse's strange darkening. Betelgeuse, which may be as close as 724 light-years from the Earth, despite the fact that other distance estimations put it further away. A difficult area of astronomy is estimating the distances of red supergiant stars like Betelgeuse. Despite the distance, due to its innate brilliance, Betelgeuse is one of the brightest stars in the sky, about 100 million times brighter than the Sun. Such brilliance comes at a price, however, as Betelgeuse's enormous energy quickly exhausts its fuel, hastening its demise. Eventually, the star will exhaust its fuel and collapse under its own weight. Its primary nuclear fuel has been used up, therefore it will eventually meet its end. It will supernova explode and finally transform into a neutron star, or more likely, a black hole if our current assumptions are right. Is Betelgeuse a threat to the planet? Without a doubt, a supernova, the worst repercussions would result from an outburst that happened within a few tens of light years of Earth. We couldn't ignore it if one of our close neighbours, Alpha Centauri, decided to behave in this way because a supernova explosion can produce light comparable to an entire galaxy. Although it would be bathing us in the radiation of all types, it wouldn't matter if it shone as brightly as the moon. We've not seen a supernova in our galaxy since 1604. Nevertheless, in 1987, one erupted in the massive Magellan Cloud, leaving behind effects that can be clearly seen even from 169,000 light-years away. It's a good thing the big cloud is so far away, even if there was no risk. Working with a hazard zone surrounding a normal supernova is an intriguing idea. What would happen if a supernova nearby erupted? The biggest explosions in the universe are not supernovae. In contrast to gamma-ray busters, they seem very insignificant, yet that is quite a different matter. Supernovas are bad news because they can wipe out biospheres and blanket entire worlds in deadly radiation. A specific form of supernova has the potential to destroy the ozone layer of a planet years after the explosion. A recent study identifies a new possible threat. When stars explode in massive explosions, known as supernovas, they can momentarily reach some of the highest luminosities in the universe. One supernova can outshine the light of hundreds of billions of stars put together. Will a Betelgeuse supernova obliterate Earth? When the star goes supernova, it will be the second brightest object in our sky after the Sun. Betelgeuse, which glows brighter than a full moon and is over Betelgeuse light years away from Earth, will be visible during the day. At the peak of the explosion, it will be so brilliant for a few weeks that shadows will be cast even in the dead of night. A supernova's visible light output accounts for a very minor portion of its overall energy production, despite its terrifying brilliance. Furthermore, although prolonged exposure to high levels of visible light might cause blindness, it often has few other negative effects. More worrisome is the high energy radiation associated with the supernova, which often manifests as X-rays and gamma rays. The ozone layer that protects the Earth can be destroyed by high energy radiation by catalyzing the oxidation of oxygen. Life on the surface of the Earth would be exposed to the full force of the sun's UV radiation without the ozone layer, which might cause an extinction catastrophe. A radiation blast happens during the first few seconds of a supernova, but a bigger threat follows. Cosmic rays, which are subatomic particles accelerated to nearly the speed of light, eventually emerge from the maelstrom hundreds of millions of years later. In addition to carrying a substantial amount of the overall supernova energy, they can also destroy ozone layers and bathe the planet's surface in lethal radiation. Significant concentrations of Iron-60, a radioactive isotope of iron generated solely in supernovas, have been detected in deep-sea cores and lunar regolith, suggesting that similar occurrences may have happened in the past. According to the study, the presence of Iron-60 indicates that Earth has recently, possibly within the previous few million years, been struck by a supernova ejection. Based on the risks posed by gamma rays and cosmic rays, astronomers have already concluded that we are relatively safe and that there are no nearby supernova candidates that can harm life on Earth. However, scientists have identified a new potential danger. A particular kind of supernova has the capacity to release lethal radiation that is more far-reaching and hazardous to worlds like Earth. A particular type of supernova develops when a star that is dying is encircled by a large disk of material. After the initial supernova explosion, a shockwave appears and hits that disk. The shockwave makes the disk incredibly heated, which causes it to emit a lot of X-ray radiation. This radiation travels a very long distance and has a high energy density. The ozone layer of a planet can be destroyed by the strongest X-ray supernovas by as much as 50%, which is more than enough to trigger an extinction event out to an incredible distance of 150 light-years. Such supernovas would deal a deadly two-punch, bombarding a vulnerable planet with X-rays months or years after the first outburst. Then, hundreds or thousands of years later, the cosmic rays would arrive and do the job before the biosphere had a chance to recover and renew its protective layer. Thankfully, no candidate X-ray supernova has been discovered to be close to Earth, but as a result of this research, the galactic habitable zone, the region in each galaxy where life can exist, is now subject to further limitations. The rate of star formation in a galaxy's farthest region is insufficient to supply the materials necessary to create rocky planets. The dense centers of stars, where stars live and die swiftly, are equally deadly because the area around them is frequently irradiated by supernovae. The inner edge of the habitable zone of the galaxy is likely located farther from the galaxy center than previously believed, according to a recent study. Despite periodically being hit, Earth is situated in one of the galaxy's safest neighborhoods. When will Betelgeuse start to chime? It's unlikely to happen in our lives. Nobody exactly knows when it will blow up, though. It may happen right now, or in a million years. What would the Betelgeuse supernova explosion look like from Earth? Well, although the ecosystem of the Earth won't be impacted, that doesn't mean that no one will be aware of it. Betelgeuse, which is 9 times fainter than the full moon, will continue to shine for more than 3 months following its explosion, according to Goldberg and Boer. All of this brilliance will be contained in a single point. It would seem like an extremely bright beacon in the sky as a result, which you could see during the day and which would cast shadows at night. Everyone on the Earth would be fascinated by it, and it would be unavoidable. People would be able to see the supernova for about a year during the day, and as the supernova remnant dims, they'll be able to see it for several years during the night. When it entirely disappears, Orion won't have its left shoulder. While the supernova is less of a worry than the stellar explosion, it could still have some unanticipated impacts on Earth. For instance, since many animals rely on the moon for navigation and are confused by artificial lights, the presence of a second object that is as luminous as the moon might be disruptive. The disruption of wildlife won't be the only thing astronomers would face. Astronomical observations are currently difficult. For a while there wouldn't be a time of darkness, since studying Betelgeuse would be so challenging that their equipment would break from the bright light. Astronomers also assert that if Betelgeuse does defy the odds and erupt within our lifetimes, there will be ample notice. Up to a day before the explosion, equipment on Earth would start detecting gravitational waves or neutrinos released by it. Imagine a sizable percentage of the populace staying up late to watch the light show of Betelgeuse, celebrating as it starts. But Betelgeuse doesn't have to explode for scientists to find it fast and fascinating. It's spacious and well lit, making studying there a breeze. Astronomers find it fascinating because it allows them to closely study a star that is on the verge of dying. Betelgeuse's internal structure has some fascinating physics. Scientists' best guess as to what is happening right now is based on what they already know about the star and related stars. According to that study, Betelgeuse's brightness may be changing due to a variety of factors. In fact, some astronomers believe that several dimming mechanisms might operate simultaneously. As their nuclear fuel exhausts and the star's brilliance rises as its envelope expands, red supergiant stars near the end of their lives start to inflate and generate expanding envelopes of gas and dust. However, a star like Betelgeuse has other methods to dull and brighten. Red supergiant stars also feature enormous convective cells on their surfaces, which are where hot material rises from the star's interior owing to turbulence and resemble much larger versions of those on our Sun. When that material reaches the surface, a piece of it violently explodes into space, producing a large radioactive belch that can briefly change the object's brightness. Additionally, Betelgeuse's dimming may be an indication that it will explode. A dying star often becomes brighter as material that is emerging from its surface collides. Another possibility is that this substance is enveloping the star, which would reduce its brightness. Regardless of its underlying cause, the peculiar behaviour should ultimately provide new insight into the red supergiant star's dying moments, with everyone on Earth sitting front and centre. To sum up, Betelgeuse will someday explode as a supernova, and even when that happens, it will be bright enough for us to see it glow during the day from Earth. What do you expect out of this event of the future? Do let us know your thoughts in the comment section below. And if you enjoyed this video, please hit that thumbs up. It will help us understand our audience and allow YouTube to suggest similar videos. Thanks for watching. We hope to see you at the next one.